Now we want to start looking at parametric equations. So what's a parametric equation? Well, let's go to the definition. We know the first part, Cartesian equation. Well, hopefully we know the Cartesian equation, named after René Descartes. Cartesian works on our number plane, works in two variables x and y. Now a parametric equation is one that's a little bit different because it works in one variable. So basically we want to put x and y into terms of one variable. So in case of this one, if x is equal to t plus 3, y is equal to 2t minus 5, we could write it as coordinates like that. So notice there's no x, no y now. It's only the same pronumeral. Now, we'll often see t, p, q. Not always. We could see one, and we have seen one. If you think about back to the 2-unit course, to this situation when we had a unit circle, and we had a point on the unit circle, x, y, and from that we said, well, cos of theta was x on 1, or x, and sine of theta was y. 1 equal y. Now we know from our triangle here, Pythagoras' theorem, x squared plus y squared is equal to 1. So that could be written as cos squared theta plus sine squared theta is equal to 1. What do we notice? We've gone from an equation in terms of x and y to an equation in terms of one variable, theta. That's a parametric equation. I might have mentioned it at the time, and you all looked at me like, what the? But that's a parametric equation because it's in one variable. Now, and that's the parametric equation for a circle. Okay, you've been using a parametric equation for a circle all through the 2-unit course and using different results involving that, and you didn't know it. How silly do you feel now? Hopefully not too silly. So what we've got to do is try to do that to other types of equations. And in the Extension 1 course, that main one we're going to work with is the parabola. Now, trusty little parabola, we want to put it in a parametric form. For those of you who are going to do the Extension 2 course, then we'll put our other conic sections, these are all called conic sections, of the ellipse and the hyperbola into a parametric equation as well. Because that makes it easier to solve some problems. And that's why we do it. We don't do it just for the fun of it. We don't. It's got to have a purpose. And the purpose is that we are able to make something be a little bit easier to solve. That's our aim anyway. It doesn't seem like that sometimes, but that's our aim. So to solve problems a little bit easier. So if we've got a parabola and we're back to this form, x squared is equal to 4ay. Now if we have that equation, then our parametric equations would be x being 2at and y being at squared. So we could write it 2at, at squared. Now, how does it come about? Well, if we solve them, we substitute them in, we can see that our left-hand side would equal our right-hand side. So that's the general form of a parametric equation that satisfies the parabola. It just happened that those 2 points just happen to satisfy that one nicely for us. So that's what we take as our parametric equations for that general parabola. So what about if we want to find equations given another parametric form? So what if x is equal to 8t? So notice here that a has been replaced. We've got a value for a, and y is 4t squared, or we write it like that. So what we can do is to get x back in terms of y. So we want to write the Cartesian equation. All we need to do is put t back in terms of x. So t in terms of x is probably easier than t instead in terms of y, but you could still do it. So if that's the case, t could be written as x on 8. So y would be 4 times x on 8 all squared, which gives us the x squared there, 64. The 4's cancel. The 4 would cancel with the, gives you 16. So y is equal to that. So multiply through by 16 gives us the equation of the parabola there in Cartesian form. So that's what we're trying to do. Go from parametric form back to Cartesian form, and that's what these ones do. We've got parametric form, so get x in terms of t, t in terms of x, and then do the substitution, and we can do it and leave it whichever way you like. It doesn't really matter, as long as you're getting y back in terms of x, going back from parametric form, then doing our substitution and getting back into a Cartesian form. And that's what we can do all the time. So having a look at this one, what we want to do is this time go to the parametric form. So 4x squared is equal to 4y. What do we need to do? Well, we need to get back to 4ay, because we know if we've got x squared is equal to 4ay, x is equal to 2at, y is equal to at squared. So we're able to manipulate to get back to there. So if a is equal to 1, then x would be 2 times 1 times t, or it'd be 2t, and y would be at squared, which would just give us t squared. So there's our coordinates that would give us the parametric form of the equation of the parabola. There we go. That's what we're looking to do. So same thing here. Back to identifying what a is, substituting back into 2at and at squared, and then being able to get our two values and be able to put it as a coordinate. So we've got our parametric form. X squared equals minus 6y. So again, we're going to identify the y value, the value of a. Now, what does this mean? If it's a minus 6 there, basically it means we've got a parametric, we've got a parabola that is concave down. Okay, so that's what this part's going to mean. Our x value is always going to be positive. It's just our y value is going to be negative, because when we write this as a parabola, we're going to have 3t and minus 3t squared. So no matter what value of t we take, then that's always going to be below the x-axis. That would be on both sides, the positive and side and negative side, no matter what values of t we take. And then we would get a negative, then we get negative values for t squared. So that's going to put it down there. So it's going to give us negative y values. So that's where we're going to get. So what do we mean when we take a value of t? Well, basically, values of t will give us, depending on our values of t, that will give us different coordinates to plot and put on our xy plane if we want to put it there. So when t is equal to 0, well, both those are 0. So that's where we get that one at the origin. So that's where we're saying t is equal to 0 there. T is equal to 2 over here. Well, it gives us 6 and minus 3 on 2 times 2 squared. So you see it was going to be across 6 and down to our negative values. Minus 0.9 will put us 3 times minus 0.9 will give us put us over in that direction, so in the negative x-axis. But because it's minus 3 on 2, t squared is positive, so it's going to push us down into the negative, because that was that negative there. Minus 2 means we're there. The further you go along, the higher your value of t, or the lower approaches infinity that way, and positive infinity approaches positive infinity. It just gives us those different values. But that's what it means. So we're getting different values of t, gives us different points on the parabola. And in this case, it's concave down, so we have to identify that. So again, concave down there. So what happens if x is minus 14t? Well, that's going to give us our minus 1 on 28x when we do our manipulation. And put that in. Because it really doesn't matter whether it's minus 14, whether that's positive or negative. Because t is going to be in terms of x, and we're going to square it. So it's not going to make any difference there. It's really the minus in front of the y, which tells us, with the y there, it tells us whether it's concave up or concave down. There's 4t minus 2t squared. So again, put t in terms of x, sub it in for t, and you get concave down parabola. So the minus there tells you about the values. 2at, at squared, well, this is our general form. Okay, we're coming back there, so we're able to see that we can manipulate down to the x squared on 4a, or x squared is equal to 4ay, whichever way we want to do it. X is 2m, and minus m squared. Again, m in terms of x, sub it in so we get back to y in terms of x. All that manipulation, and leave it whichever way we like. 12p, 6p. Doesn't matter what variable, if it's in the same variable, then we can get it back in terms of x and y. So it's all that manipulation that we're looking at here. Minus t, minus a half t, so x is equal to minus c, or t would equal minus x. So that's where we're subbing in minus x, squaring it, minus a half x squared is our parabola. So x squared is equal to, and then we're going back again this way. We're practicing going from a Cartesian equation to our parametric equation. Again, we've got x squared is equal to minus 8y. The negative is going to tell you that we're going to be concave down. So that's why it's minus 2t squared. Because in this case, it's going to be concave down. So the y is going to be minus there. So in what we're going to have is 4a is equal to 8. So we get a equals 2. So 2a2, 2 times 2, 4t. I've crossed it. I had plus and minus there at one stage, but it's really just positive. We just take the positive. And minus 2t squared. X squared is equal to 16y. Again, we get back and get the 4, 2at, and at squared, sub the a in. Once we found the value of a, we can find our parametric equation very easily. See there, again, it's about getting that value of a. This time it's 40. So 2 times a times t, and at squared. X squared is equal to minus 36y. So again, 4a is 36, a is 9, it's negative, so it's concave down. So we're going to get a minus 9t squared, 2 times 9 times t, minus a times t squared. Find the value of a, sub it in, and we get our values there. And this time y is equal to x squared. Again, 4ay is equal to 1. So a is a quarter. So this time we're getting fractions. So it doesn't really matter. All it's about is finding that value of a and being able to put into the parametric form of 2at at squared. So hopefully we'll remember quickly that that's our general form for the equation, parametric equation of a parabola. So, okay, so if you get something, we get other types of curves, we're going to get different types of parametric equations. As we saw with x, with circle, we could write it as cos squared theta plus sine squared theta is equal to 1. So it's a different way of writing this. With this one, we can just write as coordinates that describe all the coordinates in terms of x and y for our parametric equation. So have a play with those. Go back over and check what we've done and how we get from a Cartesian equation form to parametric and back from parametric to Cartesian.